Okay, children. Right. Let's see this one, right? What is in this one? Yeah, in this one also, I think. Yeah, you're supposed to calculate the number of moles here fast. How do you find the number of moles, children? N equals CV, yeah? Here you have V and C are both given, huh? This is V, this is C, no? So you find N equals CV, yeah? You can find the number of moles of all these guys, right? All this stuff. So because they have given the volume and the concentration of all of them, and then you can find the molar masses of them, no? Because they have given the formulas here. Find the molar mass of all of them and multiply that number of moles by that, and you get the mass. So first of all, tell me the number of moles here for each of them. First one, is it like 0.1 here? Second one, 500 into this means 0.5 multiplied by 0.05. Hurry up. Use calculators and tell the answers, please. I don't get any answers. Why is that? I can't tell it. Just the numbers. Then again
0.0
0.025. 0.0025. What is it? 0.025.
C, it's
Second one, dear. 500 one.
for B.
Yeah, B.
Okay.
It is 0.025
For
or
B, it's 0.025.
Okay. Third one. What's the answer? Third one.
0.1.
0.1. That is the same. That's like previous one, right? Then what about this one? Third one, 2 and 1, 0.01. Going to be 0.02, right? Okay. So then this one is actually very low. You can omit it even. With HCl, it's like 36.5. You can take these numbers directly. What is this one? 98, no? 98. This one is 40, right? Molar mass is 40. What about this one? KOH. Potassium is 39 plus 1, 40. And 16, 40 and 16, 56, no? Am I correct?
Yes.
Take the molar masses, right? And now you see this, just multiply here in my mind, multiply and see this is 0.4. That's 0.1 multiplied by 40, so it's going to be 0.4, right? The 0.4 or 4, just 4. It's going to be just 4. And this one, it's going to be very small, right? 0.025 no, multiplied by 98. Can you multiply and see? This one is going to be 5.1. So these two are going to get anyway, like which one has the greater value out of those two? This one has a higher value. Here this is 0.02. This one is going to be what? Multiply if you can you use the calculator and tell it fast. I'm not using a calculator. I'm just asking from you. Yes. Tell me the answers. Use the calculator and just do the math fast. So
First one is
7.3. The last one.
first one is 4. Yeah. Last one is, what is the answer, Ravana? Last one?
0.7.
0.73. No. Yeah, it's going to be low. So you see that this one is also going to be low anyways, because this is 0.02, children. If you get some kind of a like relationship here also you can see 0.025. So 0.025 and 0.02 are like quite closer, right? Quite closer. And if you even get like 98, it will be a smaller number that you're getting, right? Even if you multiply by 98, you get a yeah, some 2 point something. Okay, so anyway, your answer is going to be well, I don't know, 2 point something, you said, right? Then the answer you can see 5.6 is greater than all these numbers, right? 4, 2 something, and then 5.6 and 0.73, 5.6 is greater. That means C, right? There was no other way you had to calculate it. Like there was a little hint here because these two numbers are getting very small, like compared to this one, 0.02, no, right? Therefore, you can say that, yeah, they are quite low. Still, you have to consider this molar masses and check because sulfuric acid has the highest molar mass in this case. So you have to calculate one and check. If you calculate this one and check, you don't have to calculate the other one because you know HCl is going to be lower than sulfuric acid, right? Like that kind of a small comparison you can do, but there's no other, like, no, that much easy way out here, right? Okay. So answer is C. Have to do a small math, but just multiply the numbers, right? N equals CV and M equals capital M into simple M, right? That one, no? Any other method used? A simpler method? Right? No, like usually you can compare sometimes, but in this case you cannot because different numbers of moles, I mean, a different number of mass, so different volumes and different concentrations they have given, that's why. Okay, what about this one? How many tons of aluminum oxide are required to produce 27 tons of aluminum? How do you say this one? Yeah, this is actually, you can tell in a easy way, children. With the combustion, like what percentage combustion, you can tell, no? You see there are 2 aluminum atoms here. And you get 27 aluminum tons. So you need to get 27 tons of aluminum. How do you find it? Anyone? Aluminum oxide you have? Like in aluminum oxide, you have 2 aluminum atoms. It's like, you can take the percentage wise, like if you take the total mass of this one, find the molar mass of aluminum oxide first. Aluminum 2, 27 times 2, that's how much? 54 plus oxygen 3, right? That's 48. What's the molar mass of aluminum oxide? Total? It's 12 and right. Here 12. I'll write it. Here it's 12 and 5 plus 1, 5 plus 4 is 9 and 110, no? 102. Sorry. 102, right? If 102 gives 27, okay, not 27, sorry. 102 gives how much of molar mass? You can say the total mass of aluminum oxide is 102, right? If 102 has, okay, can we find? Out of 102, you get how many aluminum atoms? Aluminum mass, you can get 54, right? Yeah, 54. Or you can say right up. Can we say it like that? If it, or else you have right reaction. There are 2 atoms in aluminum oxide. 2 atoms in aluminum oxide. And you need to get 27 tons of aluminum only. How should need of this? How many tons of aluminum oxide? Here 2 are there and you get 27. Like, is there like any other way of doing it easily? Like you can go by that 102. That's possible, right? 102 gives 54. So how much is given from 27? No, not multiplied like that. It should be divided, isn't it? So it's actually the other way. If anyone who did this, like how you did it, I'm going to do it, right? I was just saying now. Like how many tons of like write the reaction and see aluminum oxide if you have 3 aluminum, sorry, aluminum oxide gives 2 aluminum here. Okay. That means you're getting from 1 to 2 ratio, right? Yeah, you have to know the ratio as well. So you can go like this. If 1 aluminum oxide was there, that means how much was total? 102 grams is there, or 102 tons are there. Okay, whatever the unit, doesn't matter. If you get 102 tons, you get how many aluminum? You can go like this, no? 2 times 20, sorry, 7. Aluminum's molar mass is 27 now, right? So 2 times 27 means 54. You're getting 54 from 102, right? 102 gives 54. Like that you can go, no? Equation. I'll write it here to show you. Let's make it bigger. It's not visible here, it seems. Can I make some space here? Did you get the question, children? Anyone? Right here? Okay. Again, it's not visible otherwise. Aluminum oxide, we have from aluminum oxide, how many aluminum atoms you get? 2 aluminum atoms, right? You will get 2 from here. And you can just consider oxygen. Think it is coming like that? Never mind, right? Anyway, you get 2 aluminum atoms. So, because aluminum oxide contains 2 aluminum, you should get 2 aluminum atoms, right? From one formula unit, you get 2 aluminum atoms. That means this is 1 to 2 ratio, right? 1 to 2 ratio. So if you take a total mass of aluminum oxide, like total molar mass, take the molar mass of aluminum and check. Molar mass of aluminum oxide is 108. Sorry, 102, right? It was 102. So if molar mass of aluminum oxide is 102, and how much of aluminum you are getting? The mass of aluminum that you're getting is 2 times the molar mass of aluminum. What is molar mass of aluminum? That's 27, right? 27. 2 times 27 means 54, right? So this is the actual mass ratio. So molar, this is the mole ratio. No? If you apply to the mole ratio, you get the mass ratio. Like if you had 102 aluminum oxide, you get 54 aluminium. 54 aluminium, right? Whatever it is, the grams or tons or kilograms, that doesn't matter because it is applied to either side, right? It's a ratio, right? It can be tons 102, then 54 tons as well. So likewise, you can take ton, no grams, that doesn't matter. So 102 aluminium oxide can give 54 aluminium because the balance equation, okay? So this is 54, but we want 27. What's the meaning of that? We need half of this, right? Half of 54. Half of 54 means half of this as well, isn't it? We need only 27. 27 means half of this. What is that? It is 51, right? Yeah. The answer is that the answer? Is that the answer? That's 15, right? It's the answer.
52. Yeah.
Yeah. 51. 51, no, darling? That's 51. Because 102 divided by 2.
51.
51. So
Yeah, 50.
you can go by the reaction here, right? Just writing reaction. Are you okay with the mole ratio? I just applied it like that because I was checking with the person, like to do it with the composition. You can't do it like that, right? But you can go with the reaction and extraction. You can calculate and see how much you expect to get. It's 1:2 ratio. Aluminium to this 102. If you had 102 aluminium oxide, you get 54 grams of aluminium. So you need to get 27 grams of aluminium means you need only aluminium oxide 51 grams, right? Or 51 tons. So that's how you get the like ratio apply, ratio tally, the mass ratio here, right? I use the mole ratio and according to that, I went with the masses. So molar masses, right? Molar mass here, molar mass here. This is the molar mass of 2 times aluminium, right? Total mass of aluminium that we can get. So that's total mass comes from aluminium oxide 102. That means 27 of aluminium to get, you need half of this only, right? That's it. So anyone who didn't understand can ask again, right? That was, I had to write it faster. Okay. Yeah. Let's see the next one. If you didn't get it, tell it, right? Okay. What about the next one? 16. Dilute sulfuric acid is electrolyzed, hydrogen gas, oxygen. Right, what is the answer? It's anode. Anode cathode. Okay, it's an electrolysis question. Yeah. Oxygen forms at, is it hydrogen? Dilute sulfuric acid. So, of course, children, you're getting hydrogen gas, sulfuric acid now. What are the ions present? Sulfuric acid means H2SO4. You have only hydrogen ions.
H plus or H minus.
OH minus also there. And also from the acid, if you take, again, you get H plus ions and sulfate ions are there. That will never go out actually, right? Then if you compare the ions from the cathode, you're getting plus hydrogen plus, of course, right? Then at the anode, you get OH minus can go out because it's a lower reactive one, right? Sulfate will never go. OH minus goes as oxygen. Yeah, anode. So what happens to the concentration of the acid? Because water goes out of the story. Yeah, we learned something like this, right? If the water goes out, concentration increases, right? Yeah. Concentration increases because the acid is like getting stronger now because only water goes out. H plus and OH minus goes out. Sulfate ions are remaining and H plus are also going to remain. So that means it's going to be concentrated. Do you get it? Okay. Right. Next point. Aluminum can be extracted by, okay, electrolysis of aluminum oxide using molten cryolite. Remember that theory? Okay, which reactions take place during the electrolysis? Which reactions take place at the electrolysis? Yeah. Aluminum, the B, you can say aluminum 3 plus, gaining 3 electrons and becoming aluminum at the anode, right? And ions. Oh, what? Anode? Is that anode reaction?
Cathode.
Is that the anode reaction or cathode reaction? Just
Cathode.
cathode reaction, right? Cations go to cathode, okay? Anions go to anode. So, or else you can say the positive ions go to negative terminal, right? So here this should be this way, right? These two. Out of these two, one will be correct. Either C or D. Which one is correct? E or D?
D.
Yeah, because the one aluminium 3 plus ion get 3 electrons and become aluminium atom. Aluminium means a 3 plus ion. This is nonsense. This is the ion in aluminium. You have aluminium plus ion. If you're underlining these kind of questions, like these ones, you know, this and this, if you're underlining, like you should be like, no, calling your basics, right? The basic theories. Like if you have a problem with the basics, that's how you write aluminium plus, right? That can't be answers. Anyways, you can make a mistake out of B and D. That's okay, right? Maybe you mixed at the anode level, cathode level. So in that case, you can correct it, right? That's the problem. So here, aluminium 3 plus gain 3 electrons and will become the CCC to understand from that point. And then you can go to this side. It's oxide, yes, 2 oxide ions gain 4 electrons to become oxygen, right? Okay. We have written those reactions, which is exothermic. Combustion of methane, cracking of hydrocarbons, decomposition of water to photosynthesis in plants. Of course, cracking of hydrocarbons, or which are? Combustion.
A.
Combustion is always exothermic, right?
A.
Combustion means burning, no? So it's easy. Photosynthesis is always endothermic. And then decomposition, thermal decomposition. Of course, thermal decomposition means you break down using heat. Using heat to break down means, of course, it is also, this is electrolysis, but actually it's endothermic. Energy is taken in, right? Cracking also energy taken in. Crack means breaking down, no? Right? Again, so breaking down. So this is also typical, very simple area is there to tackle here. Look at this balance equation. They ask you for the correct balance equation and enthalpy change. The first item, there are 2 things to identify. This is 1, this is 2. Which ones you have to identify here? The first of all is easy one to identify is enthalpy change. This reaction is complete combustion. Can you underline this, please? Complete combustion is a combustion reaction. Is it exothermic or endothermic? Combustion reactions are always exothermic. Exothermic reactions show what kind of a sign? Negative or positive sign? It's negative sign, right?
Negative.
Yeah, so only 2 options are available here now. You have 2 options with negative. And then check the balance equation. Which one has the correct balancing? A or C? Check the balance equation.
C.
We have to check it actually. Yeah. Maybe 4 carbon. Yeah, 4 carbon. That's balanced. Hydrogen. How many hydrogens here? 9 and 1. So 9 and 5. 9 and 10. So it's 10. Yeah, 5. Sure, that's correct. What about oxygen is the problem? Yeah, 5 oxygen and 4 times 2, 8. 8 and 5, 13. Yeah. 1 oxygen here. So 12. 12 is 6 times 2. Yeah, that's correct. C is correct. A won't be correct because 5 will not be enough then, right? 5 oxygen means you're not having enough oxygen on the left side atoms, right? So that was very easy actually. I think the bonding lessons are easy. Bonding lesson is actually easy in the questions, MCQs, even theory papers. Bromide, hydrogen ions are react according to the equation shown. Okay, right? Some apparatus. Okay, they have given the rate of reactions here. Gas syringe, balance, pH meter. Which apparatus is suitable to measure the rate of this reaction? Balance, you need balance, bromide, and hydrogen. You need pH, what is in balance and gas syringe. Is there gas coming out?
C.
Right, telling actually.
There's no gas coming out.
There's no gas coming out.
D.
It's only D, right? Yeah. It's just only 3, right? It's D. Because balance is also not needed, children. We are not dealing with solids. Can you see any of solids here? Why do we need a balance if you are not using a solid here? Huh? Sorry?
What does
I'm not getting it. I didn't hear that clearly.
pH meter does?
It can read the pH. Directly it can read the pH value. It's a probe actually. You have a probe. It's a digital reading. You have a probe. You can dip it in the solutions that you have. You just directly read the number, like, you know, it's like a meter, like that voltmeters, like that digital reading is there. So you can read the number directly. It's just a pH number.
Sorry,
Okay.
the rate of the reaction with that?
The pH changes here, right? Because look at this, in the case of like rate of reaction means you are having here hydrogen ions on the reactant side, right? And that means when you're starting the reaction, it should be what? Lower in like pH. There should be lower pH. When as you go on, the reaction changes to what? Neutral, no? It's water here, bromine here, they're neutral. So what happens is the pH changes, increases. The increase of pH you can see from lower number to 7, neutral number, it increases. So change of rate of change of pH according to time. Okay. Change of pH
Okay,
with that
Nikita.
time also we can check, darling. Like that we can check. Now, according to this question, there's nothing else like that's working. That's why. Like you don't need even that detail. I mean, it's like, okay, you can use it, but still you can say there's no gases. No, darling, there are no gases here. See? There are no gases produced. So how can you use, what are you going to use the gas range for? Right? The second thing is there's no solid use also. So if there's no solid use in the reactant side, why are you using a balance? Right? But only thing is the other thing, like you can see that there's hydrogen ions here on this side and water on the reactants product side. That means we can do something with the pH meter, right? pH, you have heard the pH paper, pH solution that gives a color change at least, right? So you know that is the only possible answer. Right? A bit difficult with the pH meters idea for you maybe, but other two you have to rule out the other like not possible answers. Then you're left with the correct answer, right? Try to rule out the answers which are not possible. Okay, next one. That's calculation. That's that's a skill actually. Right, in MCQs. You have to rule out the wrong answers. Yes? The answer is C, darling.
C.
Okay, I'll check it. I'm not doing that. 21. Yeah, they say 21C. That's correct. Let's check that. P uses higher temperature and Q uses 25 cubic centimeters of. Oh, there are two different graphs drawn, right? Isn't it? So P uses a higher temperature. Yeah, of course. P must be using a higher temperature than the normal one. First experiment. Oh, like some explanation. That explanation works it because it's steeper. P is steeper than X, so that means it has to be higher temperature or higher concentration or like that, right? So Q is what? What is Q, dear? They said uses 25 cubic centimeters, so more dilute acid. Yeah, true, right? If you use more dilute acid of the same volume, more dilute. That means what? Do you have the same number of moles or less number of moles? If it's diluted, it's like less number of moles. Just consider an example if you don't understand. 25 with one mole, just take the 1 mole as a dilute one, right? 1 mole concentration. 25 you can take as 0.025, right? And then again 0.025 with what? Consider 2 moles, right? This one is strong, right? You see the number of moles is great. That means our product or the total product or the volume should be higher in a case of a higher concentration, right? According to this question, they say more dilute one. So that means like this option, right? If you have option like this, yes, you get a lower product or lower total mass, right? Lower total volume of gas. So not a value. In this case, not a mass, it's a volume of gas there, right? Not mass. So it should be low. Yeah. The dilute one it should be low than the normal one.
D correct?
So there, B or D, you're saying. P uses smaller pieces of solid.
D.
Okay, wait. P uses smaller pieces of, sorry, that's correct actually. P is correct actually. P will be okay because smaller pieces of solid can do this rate increasing. Yeah, it can give a steeper result. That's true. Q uses larger pieces of salt. The point is this there. The issue is if you use the larger pieces, but the same amount they have not mentioned the amount is different, right? Only the larger pieces. The meaning is you're using the same solid, same amount, right? Same N. Only the size is different. The bigger pieces and the smaller pieces. Okay. So in that case, the volume. Yeah. If you use the larger pieces, you get the low. I mean, like look at this. I'll try to draw it. You will get the graph.
The same.
No.
At this.
What do you mean? I didn't get. The line is wrong. This line, the way they're leveling off is wrong. If you get the larger pieces, yeah, the line should be like slanted. I mean, it will be steep, the less steeper than the first experiment, but total mass will be the same, darling. The total gas you get is the same because it's only a change in the surface area, not the amount. Do you get that here? It is not affecting the number of moles. You have to consider like that because they have not specified here. You have to think that. I know it's unfair by the children when they don't give that particular word saying it is taking the same amount but different. Okay, smaller pieces, larger pieces. They have not mentioned, right? But that part we have to infer. We have to understand. That means they are only mentioning P uses smaller pieces and Q uses larger pieces. They didn't say that this affects the mass, right? They didn't say that we take the different masses. That's why. So the total mass won't be affected. Do you understand that, dear? Are you okay?
No, teacher, like,
The
no.
total mass won't be affected. The point is this. You're changing the size of the piece, right? Like just think you are taking chocolate, a big
Okay.
chocolate, right? You can break it into smaller pieces, right? Like this, many pieces. Same chocolate. You can take same size chocolate, you can make into like four pieces. Okay? Which one will react faster? Okay, which one will dissolve faster?
The one with the smaller
Smaller
pieces.
smaller pieces will dissolve faster. But will you get a different, like if you just dissolve it properly, I mean, if you completely dissolve it, will you get a different taste from different solutions? I mean, oh, is it the same taste? Because
Same taste.
like finally, I mean, after dissolving the whole thing, you will get the same taste, right? That means the maximum product or the total product is not affected, right? Do you get that point? The total product is still the same, no, darling. Only the size affected that increase the rate. It can only increase the rate. That means the steepness of the graph will be lower here. In this case, it is in larger pieces. And so in that case, the graph will be less steep. That's true, but the maximum product will be the same. Same product. Like the same mass. Mass didn't affect. Get the point now? In the case of concentration, it affects because here
Yes.
they are telling the volume is changed. Like volume is constant, concentration change. That means, of course, the number of moles affected, right? You take the same volume, but different concentration, less concentration. So there you actually affected the number of particles, the number of moles, right? In this case, it was not affected the mass. That's why. Okay. Yeah, you understood, darling. Right. Any other question? There was another one. I'm not telling your name actually here. Just tell if you don't understand that point, right? You get it sorted. Yeah. Okay. Next one. If not, I'm going ahead. Nitrogen dioxide question. Yeah, there's a color also, children. Nitrogen dioxide is a brown gas. You know, right? It's a dark brown gas, right? Which causes but pollution, no? Right. This nitrous oxide is colorless. Oxygen is also colorless, right? So what happens here? More oxygen is forced into the flask. What you get? It's a reversible reaction. So it's easy. Reversible reaction. It becomes darker. What happens? You're putting what? What are you putting? What I wanted, more oxygen is forced into the glass. If you put more oxygen, what will happen to the reaction? It will go backward, no? More concentration of the product. One product is increased in concentration. That means there's more chance of production of NO2 back, right? Nitrogen dioxide is more produced. More nitrogen dioxide is produced. So backward reaction is favored. Yeah. The thing can get
It becomes dark.
Yeah, it becomes dark because you're getting more dark side. I mean, the backward reaction will be favored. Nitrogen dioxide will be produced. It's darker. You can't tell anything else, right? Is that the answer? Yes. Question number. Is it the question number? What was the question number? Question number 22.
22.
Yeah. Okay, we'll see. 22 is, yeah, it's A. Correct, right? Okay, what about anything else? That's reasoning, the reasoning power. What about next one? What is an observation of an oxidation process, children? In an oxidation process, what happens? Blue copper sulfate crystals turn into white powder. It's not oxidation actually, yeah. It is just heating, right? You know, that's dehydration. No, sorry, removing the water, right? So copper being deposited on the cathode during electrolysis, is it oxidation? Is it copper deposition, like oxidation or reduction? Cathode is like, at the cathode reduction happens, right? Yeah, copper, it's actually copper ion becoming copper metal. Copper ion is 2+. Copper is the ion from solution. Copper 2+ becomes copper metal. Copper metal is 0. So it's actually oxidation, right? Or reduction. 2+ to minus. It's reduction. It's reduction. Green gas being produced at the anode when sodium chloride is electrolyzed. At the anode, chloride become chlorine. Is it oxidation? Yeah, right? That's oxidation. White precipitation. Now, this one is actually correct. White precipitate forming when aqueous silver ions react with the aqueous chloride ion.
That's not
It's,
oxidation.
that's not oxidation ion because it's just ions changing, isn't it? It's just a displacement reaction. Silver plus and chloride minus. It's just what? Just a displacement reaction. If you had other ions, you might have other ions with these silver ions and chloride ions. Maybe you get silver nitrate and sodium chloride. So the other ions are just switching their partners. So switching the ions, you get what? A double displacement reaction here. It's a double displacement reaction you're talking about. So it's silver chloride, you're getting no oxidation or reduction, just the displacement reaction, right? Okay, so that's the answer then. No, the three is the answer. Anyone who got the B, who got that as B, maybe you mix up with B. A is nowhere near answers, okay? Or D. They are not at all
I got-
answers. What?
I got
Yeah?
I
What is
got
it?
B as the answer.
B as the answer. Yeah, copper mixed up, right? Yeah, you have that problem, I know. You write some crazy ionic numbers in the paper today too. I saw that. Right, copper. You have to read the sentence carefully, yeah? You have the problem with reading the copper becoming copper metal. Copper metal is always zero. It's an element. Remember that point. If it's iron is the charge particle. Iron is a charge particle. Metal is not a charge particle. It's just zero. Right, next one, 24. An aqueous an excess of copper iodide ion is added to acidified potassium permanganate. Which row is correct?
B.
Iodide is oxidized and the color will be brown, right? Iodide becomes iodine, isn't it? It is oxidizing, no? Iodide is I minus, right? Iodide, no? You need to know how to write iodide minus I minus ion, and it becomes iodine here. So only can become sorry, what am I writing? Iodine. So this is iodide, two iodide minus ions becoming iodine, and potassium permanganate is an oxidizing agent, of course, you know. So this is the higher state, oxidation state, +7 side. So oxidation state is highest and it is only oxidizing the other guy. So this should be oxidizing, right? Of course. And the oxidized color will be brown because this is the colorless one. Iodide is colorless. Iodine is brown. So those are again theory, yeah? Straightforward theory. The issue is you have to memorize some stuff. Okay, next one, 25. Again, a reversible reaction. What was this one? Which statements are correct? Ammonia is an
25B.
alkali. Sorry, is it B? What?
B.
B, you're saying. Ammonia is an alkali because it
A.
produces hydroxide ion solution. That's correct, actually. A is correct. pH of this solution is 7. Is pH 7 here? No. Because of hydroxide production, it won't be 7, right?
It's gonna be basic.
It is slightly basic. It's this. I know, children. You have seen this in the weak basis. This is the example they take on the weak basis, right? Weak basis. We told it's a base actually already, right? It's a base. Though it is weak, it's base. So H minus ions are there, right? Little bit at least. So that's why you're getting the pH low or higher. pH is higher. Ammonia is a basic substance. Ammonia gas is basic, or the only basic gas in your syllabus. And ammonium hydroxide is a base, right? Okay, so don't take it as 7 there. Adding hydroxide ions to the mixture at equilibrium produces more ammonia. Is that correct? Yeah, that is correct. Because if you add hydroxide to this side, if you add more, what happens is the reaction will be, going backward, right? It will happen backward. So you're getting ammonia back. Yes. So that's let's see, 25. The answer is, B. 1 and 3 only. Okay. Right. 26. The answer. 3 dilute solutions of acid, each with the concentration here, and are reacted separately with excess calcium carbonate until there is no further reaction. Same volume started. Okay. Carbon dioxide produced, collected, and all measurements are taken at the room temperature. Okay. What's the answer?
D.
Here, what is the question actually? pH and the volume of carbon dioxide. Oh, you are saying pH higher means you get what? Or lower pH means you're getting more carbon dioxide, isn't it? Right? Acid 1 and acid 2 has the more carbon dioxide produced. So which identities are the for acids? You can say
Second one is sulfuric acid. And
yeah,
first
darling.
one is HCl.
Yes, the second one is sulfuric acid because it is giving more carbon dioxide, right? Okay, it is more.
Not into
Oh, they have
pH.
mentioned the story. Have they mentioned the stories? Something? Wait. In the same concentration, right? Okay. They're telling the same concentrations as well are reacted to separately excess calcium carbonate until there is no further reaction. Okay. Same volume of acid is added each time. Okay. They're adding the same volume of acid as well. And same concentration as well. Okay. Yeah. Acid concentration is also same. Volume is also same. But you're getting different amounts of gas. That is because of what? The amounts of hydrogen atoms or hydrogen ions that they can give. That is depending on the hydrogen ions, right? How much of hydrogen ions can these acids give? So sulfuric acid is the one that can give the highest number of, like, in this case, if you have the options, in our options, or 3 options, we have only sulfuric acid, nitric acid, sulfuric acid, hydrochloric acid, nitric acid, and ethanoic acid, right? Ethanoic acid is a weak acid, you know that. So it should be the one that has the pH 3.4, right? Ethanoic acid should be the 3.4. Anyone who can rule out that? Easy, no? Right? That one should be easy because it has a little higher pH than the others, right? 3, 4, weak acids usually get 3, 4, 5, like pH, right? So this is 3.4. It should be ethanoic acid. So what answer can be correct? A or B? Which one is going to be the sulfuric in the second one? 1.7. Yeah. Nitric acid can't be that much of a powerful one because nitric acid only has one hydrogen. Look at this. In nitric acid, only one hydrogen and it's there just like HCl. Okay. But if you take sulfuric acid, you have 2 hydrogen ions. Yeah. 2 hydrogen ions. So they can be. Yeah.
Is sulfuric acid more acidic than hydrochloric acid?
Yeah, it's more acidic means it has more hydrogen ions, right? If you take the same concentration, how many hydrogen ions this one has? 2 hydrogen ion concentration, 2 moles. Like if you take 1 mole of acid, it has 2 moles of hydrogen ions. And these both, when they have 1 mole of acid, you have 1 mole of hydrogen ions also because only one hydrogen ion can be given from 1 molecule of acid, right? Or else you can say like this, you can write the reaction and find as well. If you write the reaction, you know the balance equation of this carbon dioxide giving whatever the calcium carbonate, right? Calcium carbonate, you write it and see sulfuric acids have the chance of like getting what? 1 sulfuric acid will give 2 times. It's like 1 to 2 ratio, right? Or in this case, no, calcium carbonate 1 to 1 ratio. But with HCl, you need 2 HCl to get calcium carbonate to react. It's like 1 to 2 ratio. You can write the reaction and see as well from balancing equations, or just by looking at the hydrogen atoms, the number of hydrogen atoms here in the acid itself, we can say how strong the acid is. That's why we say this is dangerous in the same concentration with this one. You think always HCl is dangerous? No, even we don't use this in the like mostly we use HCl because of that. Another reason. So if you identify the ethanoic acid, then what happened to you? Did you say nitric acid there? 1.7 was nitric acid. Was that how you identify? The strong or the more strong acid, or you can. I think there's another way of telling this, right? There are many ways of telling this, children. By taking of the carbonate acid, that's sulfuric acid, no? That's also like coming under pH 1, no? You'll learn that in small days even. Okay. There's another 27 steps of pure sample sodium nitrate, how to make it. Titration is there, blah, blah. Okay. Which order of the steps are correct here?